Welcome back. Today, we're going to take a look at the relationship between two numeric variables in our dataset, music length and year of release. Now, a good indicator to suggest whether and how such relationship exists between the two numeric variables is to observe the correlations. So, without further ado, let's dive right into the dataset. So we're going to go to the Analyze, hit Fit Y by X, select Year as the X factor, and select Music Length as the Y response. And hit OK. There's our scatter plot of two numeric variables. In order to look at the estimated slope of the scatter plot, we need to go to the red arrow button and hit Fit Line. In order to see the correlation coefficient, we need to go to the red arrow bar again, go to the density ellipse, and select 0.95. We won't be covering summary of fit, analysis of variance, and parameter estimates in this session, so we're going to close these down. And we're going to open correlation. Let's start with the ellipse. The shape of the ellipse is mildly collapsed and is tilted upwards from left to right. This indicates a positive slope of the estimated fit line among the scatter plots and a positive correlation between the music length and year. The number 0.95 essentially means that 95% of the data points are within the boundaries of the ellipse. This is deeply associated with the confidence interval, but we will cover that later on the inferential part. Looking at the linear fit, the y-intercept of the estimated line reads a negative 1856 approximately. This makes no sense though, since negative time doesn't exist, or at least hasn't been discovered yet. So let's not pay attention to the y-intercept and move on to the slope, which is 1.05 approximately. This indicates that the music length of the observed albums on average is estimated to be 1.05 seconds longer after every year. Looking down at the correlation section, the correlation coefficient between the year of release and music length reads 0.285, which is considered to be between weak and moderate association between the two variables. It's important to note that correlation implies association between the two variables, not the causality from one variable to another. The best we can suggest from this observation alone is that there is a weak positive trend of popular music single album lengths over the past 70 years. How does that suggestion accurately explain the actual observations? Well, that's for the statistical inference part, which we will do on due course. But to briefly explain, the line does not accurately describe the observation, since the data points are not evenly distributed around the estimated line. If you'd like to observe the correlation coefficient from multiple numeric variables, you can go to Analyze button, click Multivariate, and put all the numeric variables that you might want to observe into Y columns. Unfortunately, I have only 3, so I'll put those in and hit OK. To briefly go over the other correlation coefficients, the number of copies sold has a correlation coefficient of negative 0.02 with year of release and positive 0.02 for the music length. Since both coefficients are very close to 0, it is safe to say that the number of copies sold has almost no relationship with either of the other two variables. So, that concludes the descriptive part of teaching statistical thinking. That's right, it's farewell time. But we will move on to the probability part and statistical inference part. Hope you'll join us again in those next two parts. Hope you learned a lot from this session, and I'll see you guys soon. This is John Shin from Teaching Statistical Thinking signing out with my sincere send-off.